Hello friends, welcome back to your channel, Sen Tutorials. I am your sir here to guide you along with the next topic on sets. Class 11 Mathematics Sets, Unit 1, Chapter 1. Today, so in the last video, if you remember, we discussed about union of sets, intersection of sets, complement of sets. So literally we have so far learned everything that needs to be known about sets, nothing much. So now we'll be just learning some maybe operations and then some applications of sets. And then of course we have a very important topic, that is a Venn diagram. So that Venn diagram I'll be doing maybe today if we have sufficient time, or maybe in the next video. So before we proceed, I request all of you to kindly watch the full video so that I also would be satisfied that everybody is watching my videos. And please, after watching the full video, please do hit the like button if you have liked. Don't forget to subscribe mainly because it would be like to get regular notifications on any new videos that are being uploaded. Watch the full video simply because of one reason, that is see, when we're doing mathematics, what happens is there are many things which we as students use in our lifetime, and then small tips, tricks with experience, not only during students time but even as teachers with experience. There are many tricks and tips, reading books, watching videos and all. We have come across many tricks and tips, but that we cannot remember all of a sudden in one time. So as we go on solving, then all of a sudden that thing that comes up, okay, that one hint, okay, I give you that hint. Again, after 5 minutes of solving, okay, I remember something. So that's why I always request you to watch the full videos, because mathematics is like a step process. It goes on and on. The more you learn, the better you become. There is never a limit. Nobody knows enough, okay, in mathematics or in any other subject. We are still learners. Even me, I'm also a learner only. So let's continue and let's try to learn from each other. So please watch the full videos. And fine, let's go back straight to the point. That is, now today we'll be just learning some quick this is going to be a very short video, but in the last part of the video, very important theorem I'm going to give you. So please don't go away, okay? Please don't go away. Laws and operation of sets. Now I'm not going to waste much time here. You can prove it using examples also, using your own examples. I'm not going to prove and waste all the time here. I'm just going to give you because it's important. So I have to give you. So I'll be giving you, and then proof. Maybe you can just take 2-3 random sets. Proof. You're going to get the proof. Okay. Some part of proofs we will also do, but as of now, number 1, that would be on laws. The first one. Laws of union of sets. Laws of union of sets. So please, quickly get your notebook, rough book, pen, paper. I hope you're ready. Right now, you can start noting down then. Chalo, I'll just give you. Okay. The first one is the commutative law. That is A union B will be equal to B union A. All right. First one is the commutative law. These are laws. So these are these laws are actually not new, right? Just to prove, I'm giving you that, okay, this sets, union of sets obeys the commutative law. That's what I have to say. Next will be the associative law. Okay, A union B union C will be equal to A union of B union C. So ASSOCIATIVE, associative law. If spellings go wrong, please do forgive me. Don't forget I'm a maths teacher. Of course, I also say English very important. Okay, so definitely no mistakes. No, ASSOCIATIVE, associative. Okay. Next, of course, we have another law, that is A union A. What are we going to get? Definitely the same set again, A, isn't it? And this law is called idempotent. Idempotent. Idempotent law. Okay, idempotent law. Then of course we have number D, that will be A union null set is going to be same as A, that is also null set union A. This is called the identity law. Law of identity. Law of identity. And then of course there's one more. I'll just try to squeeze in here. There is one more that's going to be a union. I'll just write in bold letters, universal set. Okay, universal set, universal set. Maybe slightly something like this. It's going to be same as universal set union A. That's also going to be the universal set. Okay, why? Because universal set is the big set, mother set. So A is always going to be a subset of the universal set. Okay, you can pause the video, note down. Okay. Then next on laws of intersection of sets. Laws of intersection of sets. It does obey the commutative law, that is A intersection B, B intersection A. Okay. It also obeys the associative law, intersection, obeys the intersection law. It also obeys the idempotent law, intersection A will be in A. And what about A intersection null? What will be A intersection null? Or null set intersection A? Is it going to be A and null set? What do they have in common? A, empty set. They have nothing in common. Empty A. Whatever be the set A, so it's going to be null set. Only that is going to be different. Okay. So that's not going to be called as law of identity. No. Okay, then A, what about A intersection universal set? What about this? And universal set intersection A. Universal set A. Intersection means common. So it's going to give us, yeah, you thought it right? A. Fine, correct. Paused? Done? Okay. Remember, this one represents the universal sets. Okay, universal set is the bigger set. Okay, so then that's okay. That was the second one, no? Then of course we have another one that will be called as distributive laws. You will have plenty of exercises to prove all these laws. Okay, so I'm not going to be that's why I'm not wasting any time proving all these proofs and all, because in the exercises you will have plenty to prove. That's why it's called distribution. So A union B intersection C. So that's definitely union will distribute intersection. So union will distribute intersection. So it's going to be like A union B intersection A union C. So union distributes intersection. Okay. So A union B intersection A union, something like multiplication only, no? A union B, A union C. A union B intersection A union C. Done. What about intersection? Does it distribute union? What about intersection? Union distributes intersection. So what about intersection? Does it distribute union? Definitely yes. Intersection also distributes union. So A intersection B, A intersection C, union. Fine? Okay. Okay? I'm going to rub off written. I'll pause the video and then fine. Chalo. Then of course we have the most important one. Not exactly most important, but a very important, I would say, a very important law. That is called D. Even the name suggests D. De Morgan's law. De Morgan's law. De Morgan's law. It states complement of A union B. Second one, complement of A intersection B. maybe we will prove this today. Okay, maybe we will prove this, but look here, very easy to remember. That's why I say, please watch the full video, because every question, every formula with different, we give you different tips to remember, right? So for this, I could not give you in the beginning of the video, isn't it? Now only it's coming up, so now only I can give you the video. Tricks. Very easy to remember, that is A union B, complement. You want to distribute this complement? Fine. A complement, B complement. Here also, you want to distribute the complement? Fine. A complement, B complement. One small trick involved, that is union changes to intersection, intersection changes to union. Bas. Okay. Right, A union B complement will be A complement intersection B complement. A intersection B complement will be A complement union. So when you split, operation becomes just reverse. Intersection union, union intersection. We will just try to prove the first question. Okay, so for that we will need a universal set U. A, B, C, D, E. A set A. A, B, C. A set B. C, D. So I'll just prove the first rule. Okay, so for that, let me get some details first. Whenever you do this, it's always good. I'm going to need A union B. So let's find out that. I'm going to need A complement. Let's find out that. I'm going to need B complement. Let's find out that. Let's first find out. See, mathematics always approach very systematically in an orderly manner. Okay, so A union B. A union B will be A, B, C, D. A complement, A, B, C, so it's going to be D, E. B complement, C, D, C, D, so A, B, E. A, B, E. Right. So I'm going to, I'm just going to write here, because there I need that in the proof. A, B, C, D. A complement, D, E. B complement, A, B, E, A, B, C, D. Okay. Now let's prove. Maybe left hand side. I'll approach, I say systematically. So A union B complement. A union B complement. So A, B, C, D complement universal set complement E. Okay, we have only E. Done. What about right hand side? Right hand side. A complement intersection B complement. So what is it? Since I've already done, I'm not going to write down the sets here. No. A complement D, E. B complement A, B, E. What is common? E. So you see, proved. So hence verified. So it's as simple as that. So in the other way, the second De Morgan's law also can be verified. You can note down if you want. Okay? Chalo. So in this, maybe in the next property, you can just prove by using the same sets that I've given you, and then see for yourself that it's really true, isn't it? So that's it. I think I will not be able to do the Venn diagram. So Venn diagrams, we're going to leave it for the next session. Let's keep a separate video for every topic. That's always much better and more systematic. Right? Okay. So that's the end of this video. If you've liked the video, I again request those who have been watching full videos. I believe I've given you some tips to remember. So if you've liked the video, please hit the like button, subscribe and share. And please stay safe, stay at home, study well. All the best.